All right. Hi, today we have Anatoly from Solana. Welcome, Anatoly.
Hey, great to be here.
Wonderful. I'm going to start with a cliche question as to, know a little bit about your life journey. And I've seen, you have an immigrant story. And, to just start off things, I would like to know how you got involved in the blockchain space and how, you started Solana.
Sure. You want me to start with my whole life story?
Sure, sure. Anything that, that
I
is.
was born in the Soviet Union, so and when I left, I was still a kid. I was 11, but it was during that transition period of the USSR to that part of the country became Ukraine. Um, so we still had a Soviet passport, um, and I kind of have like these weird memories of that like period of the 80s in the USSR and like how things dramatically shifted in like a span of 6 months. Um, but ended up in Chicago area, went to school at Urbana-Champaign, studied computer science, had a ton of fun trying to build a startup that was, basically after the dot-com crash, me and my friends in central Illinois were trying to bootstrap a voice over IP company, um, which was pretty tough. That kind of like post-dot-com crash appetite for tech companies was pretty low outside of Silicon Valley. Um, and my advisor at the time said that maybe I should consider a different career choice. If I had any sense, I would have gone straight to Silicon Valley and just tried to try to continue building. But ended up in Qualcomm in San Diego. In fact, Solana Beach, hence that's the origin story of Solana. and worked on performance optimizations, operating systems, like you name it. I started with working on these like 2 MB RAM, like 16-bit ARM chips. And towards the end of my career, my team was building out augmented reality on a live device. So kind of saw that evolution of hardware and mobile move at like a span of 10 years at like kind of breakneck speed. Um, and like what actually prompted me to start Solana, the project, the protocol, was that in 2017 there was this big boom in crypto, and all engineers were basically aware of Bitcoin and Ethereum. It wasn't like we were like in the dark or anything like that, but it was obvious from two things weren't obvious. One is engineers are terrible at like understanding the social impact of technology. So when despite 2008 crash and like all this financial kind of upheaval, you know, people looked at Bitcoin and thought, oh, it's never going to work. It's too slow. Like totally missing kind of the idea of like self-sovereign and currency. And similar with Ethereum, right? Like you kind of like thought, oh, that's a cool universal computer, but it's way too slow. Um, and like that that part that was missing was the how like transformative cryptography can be to humans and how quickly it can start, replacing the kind of financial applications we see in the traditional world with something much cheaper, simpler, and trustless, in the kind of this, I don't know, universal computer world, the blockchain world. Um, but I looked at the problem in 2017 as more of a scaling problem, and I had 2 coffees and a beer. I was up till like 4 in the morning, and I had this kind of eureka moment that you can take a puzzle similar to proof of work, and instead of measuring entropy, like the amount of electricity that goes into solving the puzzle, you can measure time, strictly time. Um, no matter how much electricity the attacker had, or how many cores or CPU or silicon, they're still bounded by the time it takes to solve it. And time is this fundamental thing that's part of wireless networks really from day one. So this is why I was like, oh man, I've got it. Like that was like really what started this. To give you guys some intuition why that's important is that first radio towers came up. You remember like your physics classes, radio waves interfere. So two radio towers transmit at the same time or at the same frequency, get noise. So the first thing that people did was they gave each tower a clock so they would alternate by time. And this is really the earliest radio protocols were time division multiple access, what later became 2G cellular networks. But the better clock you have, the more fine grain you can start rotating those slots, and the more participants you can have transmitting information per second. So once I had this like realization that we have a source of time outside of consensus that works exactly the same way in blockchain networks, because the problem you're trying to solve is two block producers producing a block at the same time. This is why Bitcoin has this 10-minute difficulty adjustment. This is why Ethereum 1 has this 12.5-second one. You're trying to prevent forks, right? If two block producers produce a block at the same time, you get a fork. But if you have a source of time that is cryptographically trustless, secure, outside of consensus, it's like, universal clock, you can avoid all that complexity and all that slowdown that you get with difficulty adjustments, even with things like Tendermint, that sequential block choosing. You can build something like TDMA, and then you can start optimizing the block times down based on just hardware speeds. So that was really kind of what prompted me to start Solana, because I realized that like once you have this clock, the rest of the problems are, they're hard engineering problems, but they're not computer science problems. Like you parallelize everything, you parallelize consensus, you parallelize transmitting the data, and parallelize how I end up with something that looks like a modern optimized database that can scale as hardware improves. And that's really the key part, right? We want to stand on the shoulders of giants like NVIDIA, right? When we started, we needed 4 GPU cards to get to 1 million signatures per second. They just released a GPU card with 10,000 cores that does 7 million signatures per second. That was just a span of 3 years. It wasn't even doubling every 2 years. Sometimes stuff moves at much faster.
Yeah, that's very interesting. And so you have proof of work that you just described. Proof of history that you just described. And so it's on top of proof of stake.
It's more of kind of outside of. It's kind of like this universal constant. It is literally like a proof of some events happening in the past. Everything has to be a proof of something. Underneath the hood, it's what's typically called the verifiable delay function. And we have a very, very rudimentary one, nothing sophisticated about it from a cryptography perspective, but it's very easy to work with and very cheap and easy to verify using modern day silicon. So proof of stake is the Sybil resistant mechanism that kind of creates a voting power in the network. And this is kind of like the beauty of proof of work, is that solution kind of solves both Sybil resistance and weight and financial allocation and like coin distribution and safety and security. It's kind of magical, right? Like Nakamoto consensus and proof of work, when you kind of really start thinking about it, you realize that so many things are intertwined that it's really hard to tease it apart. Proof of stake is much closer to traditional like solutions to Byzantine fault tolerance, to the Ant generals problem. You can almost treat all of these like proof of stake systems as some variant of Tendermint, right? Like some variation of PBFT that kind of behaves the same way. The only reason we even have this proof of history thing is really for optimization, right? It's still PBFT, it still has voting like proof of stake. The mechanics are very similar to Tendermint, but because we have this external source of time, this really behaves more like cellular networks, TDMA. In fact, like most cellular network implementations are Byzantine fault tolerant for a lot of faults, because when towers go down, your phone doesn't all of a sudden stop, right? Like it just switches to the next one and figures it out, right?
Yeah, you have a history in that. You worked at Qualcomm, and I was doing a little bit of research, and so you've built operating system. You worked at the kernel level, and you were there when there were flip phones. So so I think that's a amalgamation of that experience that
Yep.
has gone into Solana. I think you've mentioned in previous interviews that the Bitcoin is like the Mount Rushmore of the digital world, right? It's proof of stake based, and and everybody in the field kind of considers it's a store of value, and then projects like yourself and others are building other stuff. um, I just like to know your thoughts on what do you think about these two consensus mechanisms, and then I can uh, go to the other questions. Is like, what do you think proof of stake and proof of work has? Like, some of the pros and cons you feel are going to be there. Uh, between two of them.
Yeah. Proof of work has this really interesting property that um, even in like catastrophic violations of safety, you end up securing the chain even more. like the only way that you it's got this property where safety increases even when in times where you have violations of safety in the recent blocks. So like the Ethereum Classic 4,000 block rollback, that added more energy to secure all the blocks prior to that. So in like in an environment where you have mature proof of work chains, you end up in the situation where you have security that comes from just attackers trying to roll back blocks. Um, and this is why, like, you know, it's a totally different kind of like thought process. You're looking at a chain where if you're thinking about store value and like storing like gold that you're only going to store for like 100 years, 20 years, or something like that, what you care about is that the older transactions never get rolled back, right? You have this like guaranteed of state. That's very hard to replicate in proof of stake systems, and I'm not sure if anyone's close to that. But the problem that you see with proof of work is what we see today is you have three mining pools that have accumulated most of the hash power, and they kind of control all the inputs and outputs into the system. So if you're ever censored, right? If you're like in a position that you're, say you're a hedge fund and you're transferring dollars between Coinbase and Binance, those three mining pools control which hedge fund gets to transfer those dollars first. So for like typical day-to-day operations, which we don't really think of as like store of value that's going to survive the apocalypse, those three mining pools exert a ton of power and really hard to dislodge them. Um, so you can almost think of it that like, proof of work is an availability system, but it's really optimized for consistency, where you're favoring that the safety of the system over anything else. But the proof of stake systems have this problem where if certain percentage of the network ends up being like malicious or hacked, right? Like more than a third of the network typically in systems, either the network halts or they can actually split the state, right? They can create a fork. And slashing and all these other things are trying to kind of punish users from doing that, but attackers are often not the users, right? Attackers sometimes just break into a system remotely, like due to a bug in the software, get a hold of all the keys, and you end up in a situation where the punishment doesn't actually impact the bad guys, right? So, and that fault is created, and those faults are somewhat catastrophic. They're catastrophic in the sense that when Ethereum Classic had similar problem, right? Like 4,000 block rollback, it meant that 4,000 of state transitions to history gets destroyed. If that happens in a proof of stake system, there's no way to reconcile it without actually doing a governance vote, like figuring out, okay, which fork is actually the real one, and that's the one where that everybody switches to. And that problem, right? Like that problem of us having to decide, falling back to humans to governance, means that it can't really be a store of value that survives every possible like failure point, right? Imaginable. Like these are like fundamental differences that I think only become interesting when you start approaching very, very large numbers of validators. Like if you have 100,000 validators, those faults become incredibly improbable, right? Because you have a network that is so connected and so hard to hack, that large number of systems, that it almost like, it's a consistency system that tries very, very hard to optimize for availability. So it becomes very hard to shut that thing down. Does that in fact have the same properties as proof of work, right? Like it's two approaches from two different points, but really hard to know if they can ever cross or touch. So the industry is just really not mature enough to know that.
Anatoly, speaking of validators, right now, and this is publicly what y'all have on the website, it's like a little over 650 validators. How many validators does Solana need to reach that point in which you're describing, right? Of necessarily, you could say network invincibility. I don't know if that's the right term.
Yeah, this is like, again, I don't know. like so yeah, on mainnet we have 650. We started with 40, so less than a year ago we just had 40, which has been crazy amount of growth. On the testnet, where we usually, like when people onboard, because Solana's a little harder to run, we go run it in a testnet first, and then you can get a grant. Although it's permissionless, anybody can jump on mainnet. We just kind of want to give people teach them to learn the ropes, so to speak. There's almost 1,200 on mainnet, so it's kind of growing like crazy. But I don't know what that number is. Like that magic number needs to be high enough to where like somebody from boring Wall Street, Bank of America kind of place, their like chief security officer looks at it and like, oh, there's so many independent parties, it's impossible to break. Like it needs to kind of pass a gut test for those folks. And I don't know what that number is. For me as an engineer, I think once you get over 10,000, it becomes hard to fathom that system breaking. And like, 10 to 20 to 30, there's some point where you're like, okay, 100,000 definitely to me feels like, okay, there's no way this thing can break. Then you start then you're going to start doing analysis. Is it really 100,000, or is it like 10 guys running 1,000 nodes each?
I like the fact that the staking requirements are very minimal. I think it's uh, next to nothing compared to like ETH and others. And
yeah, this comes entirely from the fact that how we're scaling is with hardware, which means that if you have systems that can process the messages, then the only spam resistance you need is the fee to pay for the message, right? Like, and to me, I thought this was the obvious thing to do, but I don't know. a lot of folks went the other way.
So what kind of security assumptions does Solana have? eh, Having a proof of staking system.
Yeah, there's it's basically similar to Tendermint. There's some differences in terms of like no more than 25% of the stake can change every 2 days, and those epochs and percentages of thresholds of what can modify impact those security assumptions. But kind of at the high level general sense, it's 2/3 to get to supermajority to get to a vote. So you have to compromise a third of the systems plus control all the messages in the network, like the network routing, to be able to do double spend, or you need to compromise full 2/3. And that latter requirement to control the network layer is we're kind of geek out on networking. we make it really hard to do that because our system is UDP, and there's no connectivity, there's no sessions between any nodes. It's very hard to eclipse any of these machines. So they literally communicate to each other at random. So you can almost treat it as a super connected network within like a span of small amount of time.
Tower BFD is that the, if I'm right to say, is that the consensus mechanism that
Yeah.
you have?
Yeah, we basically looked at the PBFT implementation, like the Tenderman one and the PBFT paper. And given that we have this central source of time, this universal clock, we just started optimizing. But I wouldn't really call it a new consensus mechanism. It's just an optimized version of PBFT.
Gotcha. Okay. Matt, you have anything, or should I?
Yeah, this is more a personal question about Anatoly, your past. You mentioned that you had gotten into a little bit of AR. I'd just like to learn your insights on that. I worked in VR for a second. It was too early when I was working on it too. And your take on that, as opposed to going, you know what, I'm gonna do a blockchain project and not maybe a VR AR project, right?
This was like something that was brewing in my mind, right? Like at that time too. I really wanted to get into AR VR because it's still at that level where you need like a bunch of hardware improvements, firmware improvements to get to that, like to get over the threshold, like cross the chasm, right? Like whatever you want to call it. The problem is just latency and pixels, and you need more pixels to fool the eye. The more pixels you add, the more hardware you need. The hotter things get, the heavier things get, the more battery power you need. Like they're like similar constraints as building like one of these blockchains. Like is because the more nodes you add, the more messages you're processing. That means there's less capacity for applications, right? Like it's all intertwined. So these are fun problems to chew on. I just happened to I didn't have any insight in AR VR where I'm not like a display guy, right? Like that's like if I spent like a decade working on displays, I could have known how to like quadruple the density ahead of everyone else.
So okay, so Solana has a high TPS, and then it has lower staking costs. Then it also has the do you have any stable coin on top of it that you guys are working on? I think I saw
So
something recently.
USDC, right? Like
Right.
we have like the most stable coin,
Oh,
stable
okay.
coins.
Right.
So due to like Serum and kind of just the ecosystem growth, we've become the second largest USDC issuer. Like I think Ethereum's at like 5 billion. We're at 300 million, which is Ethereum's way further ahead on the ecosystem part. But that was over a span of 90 days, so kind of crazy. And this is just from demand from people interacting and trading and stuff like that. Tether is supposed to come online pretty soon too. We don't have. I think if you're thinking about like algorithmic stable coins or something like that, that's not quite yet out. I don't know if there's any teams that have shipped anything, but we have reference implementations for like lending markets, which you can use to base and build your own kind of synthetic based stable coins. If that's your thing, there's literally like from smart contract to UI, all the code is there. Go build it.
Yeah, I was looking through the docs before the interview, and it looks very, docs are documentation for, I come from a developer background, so it looks very easy to understand and, get you going fast.
I appreciate it, but like, there's like 2/3 of developers I think are like you and me, where we learn by failure and doing. And then a third of developers need like a very well polished
precise,
book.
well defined.
And if you're one of those 1/3 of developers that just wants to like build better docs, also reach out to us. Like we'll give you a grant to go build that awesome book. Like it's just not my thing. Like I've never read a single manual. I've always just like failed until I succeeded.
That's amazing way to learn, actually. So that's much more intuitive and learning by example and trial and error. So I think
I'm a doc. I just have to say this. I'm a docs guy, only because I'm a little stupid and I need it detailed. That's why I helped write code boot camps.
I don't think it's not at all an intelligence thing. I think it's both just a different style of learning, and it's really hard to like hit both ends, especially if you're not like one of those people, right? Like
Yeah, totally. I think I just forgot when I was asking you. So, Solana has high TPS, low staking, minimum staking or like a lower staking cost. And then the gas fees is also lower. How do you, to me, that is a very big plus point because the current issues with Ethereum and the ongoing issues with the gas fee, I mean, that's interesting. If you
Yeah,
could talk about that a little more.
this is this is also kind of a experimental, right? Like we're not sure if this is going to work, but you kind of like you can look at Ethereum as a fixed block space environment where the demand for that block space is much larger than the supply, and this is what's causing, you know, finding my transaction in, and I'm a trader, and I know I'm going to make $100 from it. I'll I'll pay like up to like $99 maybe, right? Like maybe not 99 because opportunity cost, but 50, right? And this is what's causing it to shoot up. Uh, so because of how Solana's designed, we have effectively, we don't have those supply constraints. And this is because there is no block limit. It's really a bandwidth limit. And modern day data centers, colocation places have connectivity up to 20 gigabits. Modern day like homes to fiber, 1 gigabit. Um, you know, India's 5G is 1 gigabit. Like,
Right.
right, like you live in a world where a lot of countries, we're talking about all of the world at this point, have cellular like 1 gigabit networks that are like jumping up and onboarding hundreds of millions of humans. So the backend for those is 10 to 20 gigabit. Um, so at those bandwidths, the actual block space is not the limiting factor. It's just our software, right? Like how fast can we process this data? How fast can we do the signature verification? These are problems that effectively like we can solve in a sprint, right? If we ever get to a point where we can't handle it, it's a matter of like figuring out what hardware do we need, what software changes do we need, and like ship those as fast as we can. And this is impossible to do in a proof of work system. You're always limited by that like gas limit, because if you increase that, you effectively cause the rest of the assumptions you're making about safety and availability to break. Um, so in a like a demand constrained environment, you kind of just have fixed rate for this stuff. So the way we've implemented is that we have a capacity that's kind of globally set, and whenever from a high level perspective, whenever capacity drops by 50%, fees double. And this is just to prevent spam. So an attacker that's just trying to spam the network, if they send 25,000 transactions per second of spam, the fees double. So double from a small amount to a high amount for normal users is not catastrophic, but for the attacker, all of a sudden they're paying twice as much on this very large amount of bandwidth, right? So that kind of forces them to back off. Um, we'll see if that works. We so far, right? Like I think the system is just too early to tell whether we're going to be at that point. There's a bunch of other like kind of complicated problems around fixed gas prices, because we have like a fixed instruction limit and kind of like fixed packet sizes, where it's not, you're not calling a smart contract that can do a bunch of stuff and kind of hold a lock for as long as it wants in a block up until it uses all the gas. Transactions that fire in Solana, they use fixed number of cycles, up to 200,000 cycles. If they use less than that, they don't get a refund. It's just, this is your capacity for the single message. Either it succeeds or fails. Messages time out, so a mempool can't form. There isn't even an opportunity for a large number of transactions to sit in a pool and wait to be picked up. So things like that, I think, are interesting, like interesting experiments, right? Like I don't know if like if this will work, but so far so good.
Yeah, that's mempool not getting formed is also an interesting point. How so I was checking on your website, you have something called the parallel processing, some parallel processing smart contracts, or the way to parallel process smart contracts. Could you talk a little bit more about how your smart contracts were and how work and how they are
Yeah.
parallelly processed?
So there's in Ethereum, when a transaction executes, it kind of has access to the entire global state and can do whatever it wants. And that means that it can dynamically look up accounts, access memory, meaning it can compute an address that is not visible in the transaction itself, go read or write to it in its execution. Um, that kind of like code is really hard to optimize and analyze because the memory accesses are dependent on the actual current execution. So typically, like when you're dealing with hardware like augmented reality drivers, you can't do that either. So what the technique that most folks use, like when they're designing these systems, is they force the developer to provide all the memory locations that this thing is going to read and all the memory locations it's going to write ahead of time. So if that information is known early enough, you can then take a bunch of messages that don't overlap based on reads and writes and execute all of them in parallel. But this does push this complexity up to the developer. So it's not automatic, right? Like in our system, transactions specify memory locations are going to read, memory locations are going to write. None of those are dynamic. That means that like if I want to transfer, some random ERC20 token to one of you guys, that location where it's stored needs to be pre-allocated ahead of time, and then I do the transfer. So at the UI level, you can wrap all this stuff up into a single kind of thing that a user signs, but this is again just pushes this complexity up. But the gains, I think, are astronomical because you're not doing a single threaded model where you have a single core for this universal machine for the entire financial system. You have as many cores as money can buy, right? And like I mentioned earlier, NVIDIA actually shipped a 10,000 core system for like $1,500, right? Like if you take last month's Ethereum fees divided by $1,500, it's a lot. That's, I don't know, I think 100,000 GPU cards. Literally, you can like ship all those to every validator in ETH2, and they could be they could be handling 100,000 like events per second, like easily. Like that, like that to me is like if you can build a system where all you need is money to scale it, that is kind of the true cost of, like the true goal for scaling. Like we're not blocked by engineering, we're not blocked by design, we're not really blocked by hardware anymore. It just takes dollars to go buy that hardware and deploy it. You're kind of done, because 2 years from now, this card is going to be half the price, right?
Yeah, that's the hope, and that's what's happening with technology. How many nodes are currently active on the mainnet?
Yeah, there's around 600 on mainnet and over 1,100 on the TDS. So we kind of we have this like, I don't know, it used to be a contest, like a performance contest before we launched. We called it Tour de Sol, where people like boot up their networks and then we would try to crash the network by stress testing it. That was part of the gauntlet. But it evolved into this community-based onboarding process for new folks coming into the ecosystem, because the requirements are a little higher. Like we want people to go on Google, go find a co-location in your town, call them up, ask them like, do you have like an 8-unit like rack you can spare me to set up this thing? Like go do the work, right? Like it's a bit more involved, but it's not that hard. Just like we need to hold people's hands, and then once they do it, it kind of happens. And there's literally like 8 million of these locations globally, like 8 to 10 million, some absurd amount. So how many do we need to convince the suits that this network is impenetrable? Maybe 10,000, maybe 20.
Anatoly, speaking of Ether and the gas fees, and everyone's frustrated with that. I want to build a DApp, which is coming, but in evaluating blockchains in order to build on top of this, what is the value of building on Solana's ecosystem, right? People are like, oh, I should build an Ether. You shouldn't build an Ether right now. It's pretty obvious why. So
I don't, I, I mean, like, I think our ecosystem is like rapidly growing, and we have a ton of really good backers in the ecosystem. And the design is really well suited for folks that are thinking a little bit bigger than Ethereum. You know, how many actual daily active users there are in the Ethereum network? Um, it's not that many, but it's a big enough market for you to like test whether this idea works. So this is kind of the hard problem for startups, is their most worry is like, how do I succeed in the next 3-4 months, and then worry about anything else. If you're a little bit more forward thinking, a growing ecosystem, you can be that bigger fish, right, in a smaller pond that rapidly expands, and you will expand as well. Versus in a very, you know, very crowded, bigger pond that's very hard to operate in. What are your growth prospects there? So these are trade-offs that I think are hard to make for folks. But fundamentally, like, if your application is something that you feel like you want it to go to like 100 million people, 10 million people,
Daily
you should,
active, daily active users, 100 million.
like, you're not thinking, and you're no longer thinking about, I need to grow my market within the number of users that are using MetaMask. If you're kind of a little bit beyond that, you're thinking, how do I just grow my user base regardless of where they're at? Like, how do I onboard these folks? This is like a good time for you to consider something else besides Ethereum.
Yeah, to that point, I think I'm looking for like startups that will drive adoption in places like India, Southeast Asia. Millions and now billions of people using cell phones. So something like Solana or project like that can literally come in and
Yeah, so
scale.
this is like, the thing is that, like, it's not like, not Ethereum or not Ethereum. Literally, if you want to build a non-custodial savings account, the cheapest way to do that would be to interface with USDC and Solana, and then through a permissionless bridge, pull those Aave tokens into Solana and buy them through that wallet, right? Users pay cheap fees. They have direct settlement to USDC. There's no risk there. They get exposure to this awesome lending market on Ethereum. We love the Aave folks. Stani's like awesome, like right? Like great, it works. Go launch your app and try to get it to like 10 million people in Southeast Asia, and you're done, right? Like, it kind of has like the benefit of all those things. Like, reality is that, like, the security guarantees of proof of work on ETH1 are well understood at this point, and like, people can kind of get them. New ecosystems are risky and are rapidly growing. And it's hard to know, like, right, like, you're going to make those trade-offs and try to figure out what works, what doesn't. Um, it doesn't mean that they're not like zero sum, right? Like, I almost think of it as execution versus settlement. Right, you have like a bunch of companies in the world that do execution, your stock exchange, CME, etc. You have very small number of companies that do settlement, that typically consumers don't interface with, right? Like, you interface with the execution layer, right? This is where you go do trading. This is where price discovery occurs. So those systems can be optimized for that use case. Literally, in like my cheesy seed round like slide deck, I had this thing that said Solana is blockchain at NASDAQ speed, because I was really thinking about this massively censorship resistant price discovery engine. Can we increase the number of validators that add up to that like liveness threshold to like 10,000, to where people that work at like NASDAQ are convinced that there's no way for that transfer between Binance and Coinbase to ever be stopped by any single party. No one's ever going to screw them, right? Like, the system is so censorship resistant that like those pipes, right, that interconnection between all the financial players in the world cannot be blocked at a very kind of like gut level. That's really what we're building for. So that execution environment, totally different problem than, let's build a store of value where this like piece of digital gold will never like be stolen from me. It's just, like, I don't know if you can hit both at the same time. Like, both are hard problems.
Yeah, I that's a good point. I think that settlement versus execution. That's context. From my previous interviews, I think this is a new sort of insight that I've gotten on this. That there's an execution part, and then there's the settlement, which happens in the background. Sort of, those are two. They could be totally two different things.
Well, I think about it as like the operating system for Web3. It's like, what system can I, if we're going to be able to prove people who are into crypto or love crypto or working in crypto, we're going to prove to the rest of the mainstream that you don't need to really think about building full stack applications how we used to build them. We should start building them this way. You have to have an application that is successful enough at a large enough scale that people go, holy shit, you know? And that's the real question, is which of these platforms, and as you mentioned, Solana, can really support an app that could go up to concurrently 100 million plus users and then scale from there.
So 100 million users like per day, right,
Which
is only about 1,000 TPS. The
really?
network right now idles 1,000 TPS.
No way.
You
Really?
have 50,
Yeah.
35,000 or something like that, or 50, if I'm not sure, for TPS, like on the site. What's the exact number or the max?
The capacity when we tested it at the start was about 50,000 TPS, but that's like us blasting the network with as many parallelizable transactions as we can. Things get a lot more complicated when you have so Serum is a order book that's concurrently using the network, that the changes to update in the queue, like of orders, generate about 1 gigabyte worth of accounts reads and writes. So that's taking up a resource that, if you're not contentious with that resource, you can throw as many transactions in there as you can. But there's measurement of the stuff is like a multi-dimensional problem, right? Because for simple transfers, there's very small amount of bytes read and read. For something like complicated like Serum, you have an order queues that you can parallelize the markets, but within a single market, you're almost pinned to a single core to do those trades. So it's just like an exchange, right? You're kind of dealing with 4-dimensional problem. My hope is that we get so good at this that FTX stops running matching engines on FTX and just uses Serum.
Gotcha. Yeah, that's the goal.
But
So what do you say to that I've heard debates about, like, the TPS is not the metric for a block, for any blockchain project. Any comments on that? In context of execution versus the settlement part, I think might be more relevant.
Yeah. So if you want to build a demand constrained market, if you're actually worried about guaranteeing that the fees are going to be low, you need this scalable, horizontally scalable TPS. You need the ability to, when congestion gets high, to throw hardware at it to basically increase capacity, and that's when TPS matters. This is really the core part of the scalability problem, and it's multi-dimensional because are we talking about constraints to disk constraints to memory, how much working memory a program needs, or just IO, how many events per second independent parties can send. There's a lot of ways to kind of shave this cat.
Yeah, totally makes sense. I see you got Solana is offering grants for developers. I'm very interested in builders who are in all world over also, but Southeast Asia. We got a lot of tech talent there. JavaScript guys, Java developers. So what do you say to those guys over there? How can they start building today on Solana, and what sort of incentives are there for them?
So we have a really good reference design library that has implementation to lending, AMMs, every kind of curve you can imagine. The Serum docs, all this stuff is open source. You really don't need to go into the protocol development. You can actually just start at the application layer and start plugging these pieces in, these money Legos, and build your app that's consumer facing. So if this is your vision, like, hey, I want to create savings, dollar denominated savings globally, right? Like just go do it, right? Like you have all the tools there. You don't need to be a Rust developer. You don't need to like know the nuts and bolts of finance and risk management and all this stuff. So we're happy to help. And we have hackathons. We just finished our DeFi hackathon. There's a vote on a bunch of projects. We're if you're thinking about building these applications and you want to like, how do I bootstrap myself from idea to a seed level funded startup? Start building it, submit your thing to the next hackathon. There's a path there to get funding. We will connect you to like all the investors that we know in the space. We'll help you with marketing and kind of like setting up like a business plan, actually launching. So if you've got like what it takes, the hard part in the space is actually finding those people, because everyone that's good enough to do this already has a job at Google, and like they don't need to do it, right? Like it's got to be something that's driving them from within, the love of crypto, like the wanna kind of grow beyond just a individual kind of career at a big company. So whatever it is that's like scratching your itch, those people are hard to find.
Matt, I have one last question for him. We are almost there as time wise. So yeah, go ahead if you have other questions for him, and then I think we can wrap it up in another 10 minutes or so.
I don't have too many more questions, but thanks for sharing. Yeah, I think I have an interesting vision that I'm trying to build, and it's slowly coming together, So that's my people want to know about why you
Yeah.
should build on Solana,
Yeah.
but also I'm like kind of selfish too.
Yeah. If you're thinking about people outside of just MetaMask users, like 100 million people that come talk to us, I think like you're gonna see a switch in the ecosystem from that like really soon. And it almost like we couldn't have done as good of a job as Binance to kind of like pop that bubble. Like as much as I hate them, like the fact that they just simply did it, right? And like here's fintech, it's centralized, but it has like enough of like cryptography where users have self custody and you can do DeFi stuff there. That I think opens up the world to really a ton of other applications. I think ultimately like those centralized fintech platforms are going to be like, Microsoft trying to keep the internet inside Internet Explorer. And it's not going to even last as long as that. It's going to be like them, like once the genie's out of the bottle, once a user that understands cryptography, they understand that, hey, this thing that I hold in my, like these 12 words actually mean ownership. If Binance teaches them that, us onboarding them to your application to 100 million users, right? It's just such a much easier sell, right? Like than teaching them like that first thing in the first place. So
Well, my thesis is as access is easier and easier and easier through DeFi, etc. It just changes the notion of like, you go look at Celsius network, and that's basically a social network, essentially social market network. And I think if you go look at social market networks, they're poised to overtake all their business models in the end. We'll see.
I was really like what really I loved about the DeFi summer was the social aspect of it. How quickly you had people that knew nothing about each other basically grouped together globally, right? Like without any other communication besides a token over a meme. Like, and that was 10, 20,000 people, right? Like that's it.
Oh yeah,
Like
that's a
imagine
huge.
but imagine scaling that to like even 200,000 or a million, right? And a million size social network is like nothing, right? Like Facebook wouldn't even consider crushing you, but you're like below the radar, right? Like, but
you wouldn't even matter. Yeah, you wouldn't matter
yeah,
until you're like Snapchat.
right. But like a million size group of folks that are connected through governance to like make decisions about central like financial applications. That's kind of mind-boggling how impactful that could be.
Yeah,
Yeah,
even on Telegram. Sorry, go ahead. Go ahead.
I just call it the direct democracy of the internet. It's slowly what we're building so we can take that power back.
Yeah. I mean, like the cool thing is we don't even need like for this to transform normal governance, because if we can actually organize, then it'll force that opinion will be forced itself into the whatever current system is. Current system doesn't need to change, right? Like we just need the tools to organize.
Bingo. As an activist for psychedelic medicine and having seen how activism works at the civic and local levels, yes, if we had better tools, yes, we could make massive change, because that's all the system is interacting with the system, but there's no way to do that, really.
Yeah, that I totally agree with that. I mean, it's interesting to see Telegram folks that I talk to, Discord people, like talking about XYZ token, any token, like, brings this like common ground. Even on Clubhouse, I've when I've have my presence felt there, or like, when you're in a group, it's like everybody's talking on the same topic and they're knowledgeable and you have this shared knowledge. So
Yep.
it's interesting social network in the sense these are all like separate segments of social networks that are not a single entity. So that's very, very new, uh, at least from what I've seen in Silicon Valley and other places. So yeah.
But I'm like kind of a history buff, but
Me too, actually.
this reminds me of like the city state building, because you couldn't live in more than one city, right? Like you had to be either in like Rome or in like Constantinople. You couldn't be in both. So this idea that tokens have value and me participating in that network means that I have to go like spend some of my productivity that I earn dollars with or whatever, or Bitcoin, and go buy that token means that I can't be in every possible thing. And this was missing from the internet, right? Like you could be in every Reddit group, you have a million Facebook accounts, but back in the day when we had like kind of like this governance of the street, like kind of more direct democracy, you actually had to go place your body in a specific place to have influence. And this is kind of like interesting going back to that. Hopefully with less violence, but like I'm
Yeah, the tribalism is still there,
yeah,
so it's
yeah.
and it's bound to be there, I think, or
Yeah,
it's going to be there, but yeah, like less violence, as you said.
yeah.
That's funny.
Okay, so this is my last question to you. If Matt, you don't have any questions, this might, I'm just gonna edit this part out and have this last question. So, um, what are the most exciting projects for you currently that are built on Solana? I see you have there's a big portfolio of projects that people are building different applications on it, and what excites you the most?
So Serum is really cool because it's a new DeFi primitive. It just cannot even be built on Ethereum. And it's not like a single app in a layer two, right? It is actually part of this giant universal computer that anybody can play with. So what we saw, like, literally 2 weeks after Serum was launched, was a NFT project called Soluble that was using the same tech that like the biggest market makers in the world are using to trade crypto. That were using it to sell stocks. Right? Like, and this was really cool to me. And like like it kind of blows your mind, right? That this technology is so open source that not just the softwares are used, but the actual like implementation and network and instances, like the whole infra thing is totally reused for whatever people want. Um, like one of the cool projects that's building is Star Atlas. I used to play like Ultima Online and like a bunch of massive online games. This is a like one of those metaverse games. All those things are always kind of like pull me in because like I want to see like the kind of world and like the possibilities of those worlds going to come to fruition. It'd be pretty cool to see like something like Eve Online, equivalent of that, but with this also property of persistence and like universal access that you have in blockchains. Also like you saw there's this stuff is moving so fast. Like a project Radium just hit, I think, 100 million TVL, and this is an AMM that runs on top of Serum, so it doesn't use the same, AMM style, like Uniswap style curve. It actually places orders into the order book, which protects users from some impermanent loss. Again, this is like how quickly are people launching and then launching on top of each other has been like really remarkable to see.
Anatoly, for the listeners at home, can you just explain what the acronyms TVM and
TVL, total
TVL?
value locked. This is kind of like those tokens that you have to expand, human capital or proof of work to own. You have to, for them to participate in DeFi, you have to transfer them into a contract. So a contract takes ownership of them and then does some kind of financial application with it. So Uniswap is like one of those where I take my wrapped Bitcoin and ETH and maybe USDC and put it inside pools inside Uniswap, and I get tokens back that represent my ownership of that share of the pool. But the how you calculate the effectiveness of that pool, I don't even want to say effectiveness. How you calculate like participation in that pool, you can say that the total value locked in that smart contract is X. The total amount of capital that's been placed under the custody of that contract is approach some number. There's a bug in that contract, that money's gone. so beware, right? Like and like seeing projects like Aave hit 5 billion TVL is a proof point of like the hard work that they put into making these things secure and useful, and doing both at the same time is hard.
Yeah. Were you talking about Thorchain?
No, Radium. So Radium on
Radium.
Solana is a project that's built on top of Serum. So what's really exciting to me is seeing things that are not possible on Ethereum, like central limit order books, and then projects building on top of those, and watching them get traction. I mean, that's really cool. It means that we have something kind of unique and interesting. And if it's unique and interesting, it's not necessarily zero sum to what's on Ethereum, right? We can start having these symbiotic effects.
So if we summarize the properties of Serum, what does it enable? If you could.
It's literally like the same matching engine that runs like something like FTX or Binance, but as a smart contract. So it's the same properties of bids and orders and price time queue. So how why people care about this stuff is that, when you look at NASDAQ, it handles 500,000 messages per second for about 5,000 trades. So there's basically 100 to 1 amount of information being sent into the system to the actual real trades happening. And this is really the only way to protect against impermanent loss, or this idea that when you put your assets into something like Uniswap, because you can't send enough information into that pool fast enough, that you're always kind of taking a loss on every trade. And there's awesome Twitter battles between me and Dan Robinson and folks working in Uniswap about the stuff, but this is yet to be seen if automatic market makers can have practical solutions to permanent loss. But we know that NASDAQ definitely does.
What does NASDAQ do?
They just allow more data. It's 500,000 messages for 5,000 trades, right? So traders are able to change their prices as they see information from the external world. And this is what's preventing loss, right? If I like, put my Bitcoin on sale on Craigslist and say, go buy my Bitcoin for 50,000, and price moves up to 55,000, and permanent loss is me basically selling it for 50,000 instead of 55,000, because I could not update my price on Craigslist fast enough. So that's the loss, right? That's actually like me being like losing my money. If I had, access to Craigslist at a 500,000 messages per second rate, I can always keep my price there equal to what's on Binance, and therefore never really take a loss, right? So that's really how you can think of it, is like one system is so slow that the price that it's always quoting is bad for the seller.
All right. So that
And
sort of, okay. Sorry, go ahead, Matt, if you have.
this is
I'll let it.
sorry, this brings up another question in terms
Yeah.
of like oracles and all of this stuff. Is that essentially what is being built in real time then? Is is the
Yeah, or oracles, all these problems are like intertwined. So Oracle is like, how do I even know what the current price of Bitcoin is? Do I just look at Binance? Look at every exchange, right? Like, and just because that's the spot price, is that the price for 10 million Bitcoin or 100 million Bitcoin, right? You start getting into these like really complicated problems that AMMs have a really beautiful solution to, which is, here's a math function, this is what you got. So even if you maybe quoted a worse price at the spot, for very large trades, it may actually be beneficial to all the parties to use it. And this is why these battles will go on forever. Because both systems have unique, interesting properties, so both will exist.
Yeah, I agree. I mean, I had a question regarding that. Do you have a hard stop? I can, have a
I
hard stop or
probably,
maybe go five.
shoot,
It's
I'm late for
already
a meeting.
okay.
Uh,
Yeah, so
okay.
let's wrap it up then. I had a question regarding your Chainlink partnership with Solana,
Yeah, there's
but
this.
that's
Okay, this is an awesome team called CDOT that's building out the Chainlink integration, and it's going to be the fastest, cheapest Chainlink integration ever. So we're super excited for the work they're doing.
awesome. Awesome. Thank you,
Right.
Anatoly. This is wonderful, and we wish you the best. And also folks in Southeast Asia, do check out Solana. And for more information, Anatoly, where we can check out where developers can go and get more information about Solana.
Uh, please go to solano.com. There's tons of information there, and our Twitter is probably the best place to follow us. So thank you so much.
Thank you. Thank you.
See you guys.
Yeah. I'll update you on when it's
Right.
available.
I gotta
Thanks.
jump
Yeah.
off. All
Thanks.
right.
Thank
Thank
you.
you guys.